So in this video, we are going to study about Cauchy integral theorem. So according to this theorem, if fz is analytic and f dash z, which means its differentiation, is continuous at every point within and on the simple closed curve C, then according to this theorem, integration of fz over this area is 0. Quite easy. Now, Cauchy integral theorem for multiple connected region like this. So, if fz is analytic at every point within the connected region R bounded by three simple closed curves C1, C2 and C, but not analytic within C1 and C2. So, in that case, integration of fz dz over the region R is given by its integration over the region C1 plus its integration over the region C2. Let fz be in the form phi z upon z minus z naught, where phi z is analytic at every point within and on a simple closed curve C, and z0 is any point inside this curve, then integration of fz dz over this curve is equal to integration of phi z upon z minus z0 dz is equal to 2 pi I pi z0. We are going to replace z by z0. And similarly, if fz is in the form phi z upon z minus z0 to the power n plus 1, and in this case, its integration fz dz over this curve is equal to integration of phi z z minus z0 n plus 1 dz is equal to 2 pi I upon n factorial into phi n z naught. In this case, phi n is nth derivative of phi. So now let's take some example. Okay, so now you have to evaluate this function e to the power 2z upon z plus 1 to the power 4, where C is the circle. Circle Z is equal to 3. So clearly in this case, Z0 is minus 1 and this lies inside the circle. Z is equal to 3. So by Cauchy integral formula, e to the power 2z, z plus 1 to the power 4 integration is equal to 2 pi I here. N plus 1 is equal to 4, so n is equal to 3. So 3 factorial upon pi with its triple derivative, and at point z is equal to minus 1. And here pi will be e to the power 2z and its triple derivative would be 8 e to the power 2z. So our required answer is 2 pi I 3 factorial into 8 e to the power minus 2, which is equal to 8 by 3 pi I e to the power minus square. Now this is your required answer. Okay, so let us take another example where you have to evaluate this function sin pi z square plus cos pi z square upon z minus 1 into z minus 2 dz, where C is the circle, is equal to 3. Okay, so now we know this, that z is equal to 1 and z is equal to 2 both lie inside this circle. Okay, so now we'll write fz as phi z upon z minus 1 into z minus 2. We can also write this as pi z minus 2 minus pi z upon z minus 1, where phi z is equal to sine pi z square plus cos pi z square. So now by using Cauchy integral formula, integration of fz dz is equal to integration of phi z upon z minus 2 minus pi z upon z minus 1, which is equal to 2 pi I pi 2 minus 2 pi I pi 1. So phi 2 is equal to sine 4 pi plus cos 4 pi, which is equal to 1, and pi 1 is equal to sine pi plus cos pi, which is equal to minus 1. So now we are going to put this value, then so this is our answer, 4 pi I, and this is how you are going to solve all the question related to this Cauchy integral formula. Thank you.